Okay, we're going to move on to problem 2, got it? And it's kind of the same idea as problem 2 itself. It's saying a parabolic path of a thrown ball can be modeled by this table. The top of the wall is at 5, 6. Will the ball go over? If not, will it hit it on the way up or on the way down? Well, we have 3 x's and y's, so let's start with step 1. I like to just write them down. Alright, so the first one is 1, 3. The second one is 2, 5. The third one is 3, 6. Remember, we're putting in y equals ax squared plus bx plus c. We have to solve for a, b, and c, and then we'll have an equation that we can work with. 3 equals a times 1 squared plus b times 1 plus c. Simplify. 3 equals 1a plus 1b plus c. Didn't get an answer, so we got to keep moving. 5 equals a 2 squared, because of ax squared, plus b times 2, because of bx, plus c. Let's keep going. 5 equals 4a plus 2b plus c. Didn't get an answer, so keep going. 6 equals a times x squared, so a times 3 squared, plus bx, so b times 3, plus c. 6 equals 9a plus 3b plus c. That was step number 2. Step number 3. I'm going to take my first one and solve it for the letter c. 3 minus a minus b equals c. And I used my first equation and I just solved for c. Step 4. Take what I just got and plug it into the 2 other equations. 5 equals 4a plus 2b plus, not c anymore, 3 minus a minus b. Let's simplify. 5 equals 3a plus b plus 3. Move the 3 over. 2 equals 3a plus b. Move over to the right. 6 equals 9a plus 3b plus, not c, 3 minus a minus b. Combine. That makes 8a. That makes 2b plus 3. Take the 3 over. 3 equals 8a plus 2b. Step 5. Linear combo these two. I notice that, oh, that should be a 2b. I notice the b's are going to cancel pretty easily if I multiply this one times negative 2. Negative 4 equals negative 6a minus 2b, and that came from multiplying by negative 2. Then bring the other one right below it. 3 equals 8a plus 2b. Linear combo. Negative 1 equals 2a. A equals negative 1/2. Finally, I have one answer. It gets a little easier from here. Step 6. Take this and let's plug it in. Let's plug it in this equation because I know the numbers will work out nicely. If not, you'll just have to work with fractions. 8 times negative 1 over 2 plus 2b. Notice I just put in for a. 3 equals negative 4 plus 2b. 7 equals 2b. b equals 7 over 2, or 3.5, since it's a terminating decimal. Now we solve for c. That's step number 7. We're going to take these 2 answers from step 6 and step 5, and we'll plug them back in from step 3. So you see step 3 up there? Right here's where we're going to plug in a and b. 3 minus, and a was negative 1/2, so it's minus negative 1/2, minus c, or b, so minus 7 over 2 equals c. Well, that all cancels out, and C is a whopping 0. Step 8, rewrite. Okay, y equals, you write a first, and then x squared, and then you write b, and then x, and then you write c. But c is 0, so usually you don't usually write 0. So there it is in standard form. Now the question was, the ball is going to go up, and we're trying to figure out if it's going to hit at 5, 6 or not. Well, let's plug in 5 and see if it's going to go through where it's going to be in reference to the wall. Okay, so we're going to plug in 5. So we get y equals -1/2 times 5 squared plus 7 over 2 times 5. Let's figure out where it's going to be when it's a 5. Alright, get your calculator. -1/2, 5 squared, plus 7 over 2 times 5 is 5. So it's going to hit at 5. Now let's think about this. Here's the wall. They said the wall is over 5 and it's up 6. Well, here's our parabola. It's going, but look where the ball goes. It only goes to 5 here. So is it going to hit the wall? Is it going to go above the wall? Or is it going to just grace it? Well, since we plugged in 5 and got 5, that means that it's short. That means it's going to hit the wall. And since it's short, it's on its way down. It is going to hit it on the way down. If you're not sure why it's going to hit it on the way down, it makes sense if you draw yourself a little axis here. Okay? And if you plug things in, for example, here's the wall, okay? The wall is at over 5, up 6. So we'll call this 6, and we'll call this 5. So 1, 2, 3, 4, 5. Sometimes it helps to have a visual, okay? Let's just plot quickly our points. 1, 2, 3, 4, 5, 6. 5, 4, 3, 2, 1. Okay, here it goes. It's at 1, 3. That's about here. I'm using my points from the table above, okay? There's your points. I'm just plotting them. It's at 1, 3. It's at 2, 5. And then it goes to 3, 6. And then we just plugged in 5, 5. So you can see it's on its way down. So that's why it's going to hit on its way down. As we move on, I promise you this problem will be a little bit easier than the previous ones because you're not going to make an equation. You are just going to be comparing an equation and a graph. So that's going to be nice. We're going to move on, make it a little more simple. All right. Remember, when asked to compare the max and the mins, all they're asking you is to compare the vertexes or the vertices. So you would just want to find the vertex on each one. Okay. Let's take a look at problem 2. Now we're going to have to kind of think through problem 3. So as I read it, just kind of try to picture it in your mind. Campers at an aerospace camp launch rockets on the last day of camp. The path of the rocket 1 is modeled by the equation. So for rocket 1, they give us an equation. All right. And the equation is h equals -16t squared plus 150t plus 1, where t is the time in seconds and h is the distance from the ground. The path of rocket 2 is modeled by the graph at the right. So here's your graph over here for rocket number 2. Which rocket flew higher? Very quickly, let me explain to you for any of you continuing on to physics someday. You see that -16? That's the pull of gravity. You see that positive 150? That's the initial velocity of the rocket. And you see that plus 1 at the back? That means the rocket, when it took off, was 1 foot off the ground when it started. All right, and that's just kind of intro you into physics someday. But let's keep talking. So rocket 1, we have an equation. Rocket 2, they give us this graph. So don't think that the graph and the equation are the same thing. Rocket 1, they give us an equation. Rocket 2, they give us a graph. So they want to know which one flew higher. In other words, when they ask us which one flew higher, they're asking us about the maximums of each of them. So they're asking us the maximums of both of them. They're asking about the vertex of both of them. Let's take a look at the first one. Negative 16t squared plus 150t plus 1. You guys should know how to find the maximum on this. In order to find the maximum, you simply find the vertex. Okay? Now this is in standard form. Okay, now how do you find the vertex in standard form? You write x equals, well in this case, x is a t, so t equals, or time equals, negative b over 2 times a. So negative b would be negative 150 over 2 times a is negative 16. Okay, you plunk that into your calculator and you need to get a solution. So negative 150 divided by the quantity of 2 times negative 16 and your quantity. If you guys don't put 2 times negative 16 in parentheses, you're going to get the wrong answer. Alright, so about approximately 4.7 seconds. Okay, so I'll say it's approximate to 4.7 seconds. That's time. That's why I put seconds on there. Now that is not the maximum. That is when the maximum happens. Alright, let's continue on. So if you plug that in, okay, if you plug that in, you will get negative 16 times 4.7 quantity squared plus 150 times 4.7 quantity squared plus 1. Alright, let's go ahead and plug that in. Negative 16 times 4.7 quantity squared plus 150 times 4.7 plus 1 at the end. So I get a height of 352 if we round, 6 feet, and that is the max. Again, this is going to be fairly approximate, so I'll write my approximate symbols. When I plugged it in, I got 352.6 feet, and that is the maximum that the rocket traveled. So as the rocket goes up and it comes back down, there you go. If you're a visual learner like me, the rocket goes up, it comes back down. That is the maximum. Alright, let's take a look at rocket 2. Now there's no specific example for rocket 2, but we can see by just looking at the graph that it happens at like 6 seconds, right? So this spot here, that spot up there is your vertex. It's the maximum. So we can notice that it's pretty gosh darn close to 600. So we can say that the max on this one is close to 600. So if we take a look at our question, it says which one flew higher? Clearly, if this one was only at 350 and this one's at 600, we can say rocket 2 definitely went higher.